Okay, so this is the 3.3 lesson. We're going to be talking about equivalent expressions, and whenever we get into equivalent expressions, we start to talk about some key properties in math. So the definition equivalent expressions is not really important for your notes. The two things that are super important that you need to put under the 3.3 lesson in your notes are, first of all, the commutative properties. You want to copy that down. You don't need to write these words down. We'll talk about what to write down here in just a second. But we want to write down commutative property and associative property in our paper notes. If you need to, go ahead and pause or rewind or do whatever. But first of all, what I want to do is go over what commutative property means with algebraic terms. So with algebra, let me fix that real quick actually. Let's make that a little bit smaller. With algebra, let me fix my pen, sorry about that. With algebra, the definition looks like this. We can say a plus b is equal to b plus a. In other words, if we have numbers, we can flip-flop them and we will still get the same answer. So if I say 3 plus 7, I can also say 7 plus 3, and I know that the answer is still 10. Addition has commutative property as well as multiplication. So addition and multiplication both have commutative property. Associative property, it's also addition and multiplication. Algebraically, the definition looks like this. We would say a plus b in parentheses plus c is equal to a outside the parentheses and then b plus c. Again, if we were to plug in numbers, we could say like 2 plus 5 in parentheses plus 4 is equal to 2 plus, and then in parentheses 5 plus 4. Notice how all of my operations are the same. This only works when your operations are the same. So as long as all of your operations are addition or all of them are multiplication, the grouping or the order does not matter. But you can never multiply, you can never add before you multiply unless there's parentheses around your addition. Make sure you take the time to pause this and get these notes down really good before you move to the next page. Okay, so when we're simplifying expressions, you guys, most of what it wants us to do, and when it says use the properties to write equivalent statements up here, what we're supposed to do is state what we did along the way. Notice here the very first thing that this problem does is it takes the 12 and the x that was grouped together and it changes what's grouped together to the 7 and the 12, and the property used there was the associative property. And then we can add the 7 and the 12 together and we get 25 plus x, and then the property when we add together is just the addition property. This next one has a couple more steps. First thing we want to do is change the order of the 6.1 and the x. So now what we're going to do is say x plus 6.1 plus 8.4. When we flip the order, we say that's the commutative property. Now what we want to do is group the things together that are like terms. So we say x plus 6.1 plus 8.4. And that's the associative property again. And then we just add, just like we did before, we get x plus, let's see, 5.8 and 6 will give us 14. So 14.5, and that's again just the addition property. This last one, again, notice over here they have the 11 and the y grouped together. All we did was change what's grouped together to the like terms so that we can multiply those together. We get 5 times 11 is 55. I'm putting that in the wrong spot though. What I need to put over there, because we changed grouping symbols, is associative. Then down here we put 55 times y, and that's just multiplication property. So when you go to practice these on your own, you guys just look and see what they group together, because I'm guessing what they group together in your practice problems are not like terms. So when they're grouping things together, they'll do it like this: 12 plus x, those aren't like terms. 6.1 plus x, those aren't like terms. 11 times y, those aren't like terms. So what they want you to do is use those properties of addition and multiplication to move things around. Okay, so these are some that I'd like you to try on your own. As you go through these, again, make sure that you write each step out or explain each step out like we did in those previous examples. Writing the associative property or the commutative property or the addition property. So pause now, try those, and then when you're done, go ahead and unpause. First one, we have the problem. I'm going to rewrite it: 10 plus a plus 9 in parentheses. What we need to do is change the order first. So my next step, I'm going to write 10 plus 9 plus a, and that is going to be the commutative property. Then after I do that, what I want to write is 10 plus 9 in parentheses plus a, that's the associative property. Then I want to add 10 and 9 together, and I get 19 plus a, and that's addition. Number 2, we have c plus 2 over 3 in parentheses plus 1/2. We need to change what's grouped together on this one, so c plus 2 over 3 plus 1 over 2. That was the associative property. Then we just add like terms. We want to change those denominators to 6's, so that 3 changes to a 6, the 2 changes to a 4, the 2 changes to a 6, the 1 changes to a 3. We add those two together and we get c plus 7 over 6, and you can just leave it like that and we can say addition property. Number 3, we have 5 times 4n. All we need to do is change what's grouped, so 5 times 4 needs to be grouped together, and then n on the outside. That was the associative property for grouping. And then 5 times 4 gives us 20 times n. That's just multiplication property. We have a couple more properties here with addition and multiplication. Addition property of 0, and then we have the multiplication properties of 0 and 1. The addition property of 0 is technically what we call the identity property. If you add 0 to any number, you're just going to get that same number for an output, and it shows it algebraically over here that if you take any number plus 0, you're going to get that same number. Multiplication properties of 0 and 1, we have two different things here, because if I multiply any number by 0, I know 0 is going to be my output. So here's what it shows algebraically for that also. And then the identity property for multiplication, if we multiply any number by 1, we're going to get that same number back out, and it shows it algebraically over here. So really, when it says the identity property of multiplication, you're multiplying by 1. When it says the property of 0 for multiplication, you're multiplying and you're getting 0 for an output. Okay, so technically if you just follow order of operations, you could skip this first step, but what the book has for the first step is grouping 9 times 0 together, and that would be the associative property. And then after that, they multiply 9 times 0, and they get 0 times p. That's the property of 0. And then if we take 0 times p again, we get 0 anyway, so 0. And again, that's property of 0 again. This next one, we want to flip the 4.5 in the, the 4.5 in the r, or the r in the 1. I'll flip the r in the 1. So 4.5 times 1 times r, that was commutative. Then I'm going to take 4.5 times 1, which is just 4.5, That's identity property of multiplication. So I have 4.5, so I have identity.
Bell wasn't you yesterday.
Okay, so these are the answers for 4, 5, and 6. Make sure you've tried them on your own and kind of understand the steps that I took here. The steps are all along the left-hand side of the problems here. Hopefully, when you get to your homework, that most of them will be just asking you to identify the steps.